Ryan is a specialist with the Joby Aviation's government affairs team. In his role, he leads numerous regulatory, policy, and standard development initiatives to facilitate the introduction of a new generation of safe, quiet, sustainable aircraft. Ryan joined Joby following 2 years with the Uber Elevate project. Uber's initiative to develop and launch a multimodal air taxi service called Uber Air. Ryan studied aerospace engineering at the Georgia Institute of Technology, and he also holds a bachelor's degree in economics from SUNY Binghamton. On that note, take it away, Ryan.
Well, thank you, John. Again, I appreciate the introduction and a pleasure to be able to address both you and the rest of the Empire State AUVSI membership. It's a really great opportunity, I think, to be able to speak with you all today. Joby Aviation has been developing an all-electric eVTOL aircraft, and that is electric vertical takeoff and landing aircraft for at least the last decade. And we've been in type certification with the FAA since 2015. So my presentation for you all today is really talking about how the Joby eVTOL aircraft has been designed for today's system, right? But that it is also adaptable for aerial ride sharing networks of the future, including increasingly autonomous operations, which I think are of great interest to this committee and this community. So a little bit about the Joby aircraft. We are manufacturing this aircraft today in Marina, California. Our headquarters is in Santa Cruz, California. And we also do powertrain and electronics development in San Carlos, California, which is near Mountain View, Apple, Stanford, et cetera, near the San Francisco Bay. You're seeing right now one of our full-scale prototype aircraft flying over the California Big Sur region. We've flown our aircraft now about 30,000 miles total across all of our prototypes, which is more than 1.5 times around the world, or nearly that at least. This aircraft is capable of being deployed on missions up to 100 miles in length, which doesn't sound like a lot, but when you think about regional transportation, let's say across the New York tri-state region, 100 miles is more than enough, especially when we think about the ideal mission which this aircraft is designed for, which is high cadence, repeated 20 to 25 mile trips. For example, if you can imagine flying from parts of Long Island to Newark Airport, right? Let's say that you were a United Airlines customer, or vice versa. If you wanted to fly from northern New Jersey to JFK, right? An aircraft like this can really change your perspective when it comes to moving across the tri-state region. I'm myself from New York, lifelong Newburgh, New York resident, just recently moved to Limbrook, New York. So I know the navigation of this region quite well, and how this could really change a lot of our lives. Okay. A little bit about the aircraft, and again, I think I might said it at the top. We're a type certified aircraft, right? We're not a recreational drone. I know that, for example, a lot of times when I speak to some of my family, they look at the 6 propellers here and they wonder, that's got to be a drone, right? And kind of like a drone, right? The technologies that drones pioneered in terms of distributed electric propulsion and the use of high performance batteries to support long duration flight. Sure, yeah, there's definitely some technical commonality, but we're really, in terms of the regulatory system, would be more aptly and appropriately seen like a traditional airplane or a helicopter. That also has to do with the expectations of safety, right, from the regulator and from our eventual customers. So a little bit about Joby too. We're not just building the aircraft, we are a vertically integrated transportation company. Joby intends to operate the aircraft that it builds. We don't intend to sell them to third-party airlines. We intend to operate them as a Part 135 operator. We intend to maintain them. We intend to train our pilots. We intend to essentially be a part of the entire value chain that is manufacturing and operating the aircraft. And a lot of that has to do with safety, right? We, Joby can have total control of the aircraft from cradle to grave, understand how the aircraft's operating, and also utilize it in the most efficient ways. And that's really a core principle with the vertically integrated structure. We're looking at 2025 entry into service. That is contingent, of course, on FAA type certification, but you may also have seen this week that we announced delivery of one of our first aircraft to Edwards Air Force, to the United States Air Force, who's one of our early customers. They're looking at operationalizing this aircraft because it is a low direct operating cost aircraft as a potential complement to their other vertical aviation assets that do logistics services here domestically between military bases or across military bases, which in many cases can be quite large in size, but also VIP transportation. You can imagine in the capital region, right, an aircraft like this being a direct drop in for some of the aircraft or some of the missions that they currently use helicopters for today. And, a little bit about the presentation. We're going to go through a little bit of the customer experience, a little bit about the aircraft, and a little bit about the operations. I might be a little bit redundant here as I address this slide, but one of the things that you heard is that I came from the Uber Elevate project, and Uber Elevate really was looking at how can we make air transportation across a region seamless in the same way that, we can push a button and get a ride today, we can push a button and get a flight in the future. And so what we were pioneering was what was called multimodal aerial ride sharing. The first mode being some form of ground transportation. Right here, you're seeing first mile, let's say Ubers or other new mobility vehicles, bringing people to a heliport, a place of fixed aviation infrastructure. They're pooled in like a Uber pool fashion at the heliport, joining that aircraft, which may, in this case, fly them to, let's say, LAX. And at the back end, that last mile is also seamlessly and magically coordinated. All of that is now in-house at Joby. Joby acquired the Uber Elevate project in late 2020. And we maintain a really strong partnership with Uber. This video is speaking to one of our most recent partnerships.
Introducing an innovative and sustainable way to begin your journey.
Home to airport.
Soon getting here will be as easy as getting there.
So that's right. Delta Airlines and Joby have entered into a partnership really focusing on delivering that seamless customer experience and in the airport shuttle mission. So we're really thrilled to have Delta as a commercial partner with us, just as we're thrilled to have Uber as a commercial partner with us. Joby really does take pride in its partnerships, and you can see that we have some incredible partners also in Toyota, who is one of our largest external investors, really focusing on making sure our manufacturing processes are scalable and efficient. You may have seen also in the last 2 weeks that we announced our scaled manufacturing site will be in Dayton, Ohio. So really excited about that. As you see here, in terms of operations and testing, NASA and the U.S. Air Force alongside the FAA will be doing a lot of testing down at Edwards Air Force Base. You might see us across the NASA at a couple other locations in the next year or two. And then on infrastructure, we're thinking about both utilization of existing infrastructure and developing and operationalizing new heliports and vertiports. We have great partners with Macquarie, Signature, and Reef. Reef being one of the largest parking garage operators in the United States. A little bit about the aircraft. Let's dive in kind of a layer deeper. So what you can see here about the aircraft is that, in many cases, it's very traditional, right? It's a type certified aircraft. It has a single pilot, 4 passengers, will operate at about 145 knots indicated airspeed. It has a max range around 150 miles. Will be operationalized on routes up to 100 miles. The max weight actually has increased a little bit. We're a little north of 5,000 pounds now. And, the initial aircraft will be day-night VFR, non-FEAKY. We'll in the future go through revisions of the aircraft that will include IFR capabilities and increasingly, scalable systems, right? That will allow us to operate even more efficiently and deliver even more opportunities to folks across the region. Some of the non-traditional aspects here is that it's an electric aircraft and that, it's not just VTOL capable, but it's CTOL and VTOL capable. So it can land like a traditional airplane. It can also land like a helicopter. Let's take a look on the inside. This is where all the magic is. So as you can see, 6 electric propulsion units. Each of these are dual wound, so you can actually think of it almost like 12 motors, in that there are 12 electrically isolated and independent power systems across the aircraft. These 12 electrically isolated power systems are supplied by 4 integrated battery packs that themselves are sub-modularized. So we have 28 modules on board the aircraft and 4 battery management system units. So each of those 4 BMSs provides power to 3 of the 12 EPUs, or sub-EPU systems, electrically isolated power systems. What that means is that the aircraft has a unprecedented safety and redundancy characteristics relative to other VTOL aircraft. We can continue safe flight and land after the failure of half of a propulsion system, and let's take a look at that right now. So as you can see, we're capable at each propulsion station of producing 100% power, but if we lost one of those 12 half windings or half systems, right, we still have full power capability at the station. But if we were to lose the entire propulsion station, the aircraft can operate in vertical thrust-borne flight on 4 of the remaining 6 propulsion stations. The onboard computing systems are responsible for detecting those anomalies and shutting down the systems appropriately. It's a really incredible system, and it's one of those concepts that we call simplified vehicle operations. It's when a function that traditionally had been assigned to the pilot is instead delegated to a system that can perform that function more reliably. In this case, the management of shutting down, let's say, one of these 12 or one of the 6 propulsion stations, let's say, has been delegated to the system. That system will perform that function more reliably than a pilot could. We're working across FAA lines of business quite actively, and we're nearing, kind of the last stages across each of these various aspects, be it type certification, pilot qualification, the commercial operating certificate, airspace. There's a lot of airspace modernization efforts happening, but there's definitely a lot in day one that's already suitable for this aircraft. No changes are necessary, let's say, to airspace structures in order for us to operate. Same can be said about airports and heliports, right? Very minimal changes necessary to electrify that infrastructure and make it ready for our operation. So a little bit about that operation. There's, when we talk about airports today in the NAS, a lot of us think about the 35 OEP airports. These are the ones that when we're on Expedia, right, we're looking these ones up. This is how we get to and from place to place. But what's really important to keep in mind is that, the United States has this incredible wealth of airports, 5,080 public airports, one of our last counts, across the NAS. This does not include another 10,000 or so heliports. And so what this really means is that, why is this important? Why is this something that I bring up? Having 100-mile maximum, mission range is not actually quite a terrible thing when NASA has actually indicated that most Americans live within 16-minute drive of their nearest airport, right? And getting to and from, parts of a region can be really facilitated by finding greater opportunities at our small municipal airports as well. So if you think about Orange County Airport in Newburgh or Montgomery, New York, or MacArthur and Islip, Teterboro, all the small airports in the region are going to have a huge impact on how we operationalize here in the Empire State region, but also across the broader state as well. Noise is a really big issue when we talk about helicopters and vertical flight. And, Joby realizes that its long-term vision of, moving ride sharing to the air is really predicated on the ability to have an extremely quiet aircraft. And what you're looking at here is sort of the scale, the decibel scale, right, in terms of radiated energy, right? As you can see, it's an exponential metric. The Joby aircraft is incredibly quiet, quieter than conversation and cruise flight when it's flying on the wing with the propellers pointed forward, and even quieter than a car when it's taking off vertically. One of the other really exciting things that kind of goes understated about our vertical operations at heliports is, anyone who's seen a helicopter at a heliport probably didn't totally notice this until I call it out here for you, but a lot of those helicopters stay running when they're on the ground. They radiate a ton of acoustical energy into their communities because they don't want to shut down those turbine engines and cycle that aircraft. They'll leave that aircraft running on the ground for a long period of time as they disembark passengers and wait for others to arrive. And, with an electric propulsion unit, as we all know, with our electric cars, torque is on command, on demand. And that's going to be the same here. There's really no reason for us to keep the propellers turning. As soon as we touch down, we'll turn them off. Ready to go, we'll turn them on. And that will definitely also have a huge impact, a noticeable impact in our community footprint. Saying it is one thing, but testing it is another. And so Joby in September 2021 worked with NASA's Mobile Acoustic Facility. It's that big tractor trailer you saw there, to lay out a microphone array over our Northern California test site. And we were able to then develop what's called an acoustic hemisphere. This is essentially a data package that talks about how noise is radiated directionally and at what amplitude. And it allows us to model essentially our acoustic footprint relative to other helicopters that have been measured by similar equipment. And I think that last, visualization says it all. In overflight, this aircraft is going to be barely noticeable. At takeoff and landing, the impacts are going to be, drastically less. And I cannot wait for you all to hear this aircraft in person. Having seen it myself operate in person, the thing that really strikes you is that you end up having to whisper. You kind of catch yourself whispering like, oh my gosh, did you really hear that? That's amazing. As it does some overflights. The other thing too is kind of a fun anecdote. As the NASA team was out measuring this aircraft, you can kind of see in this picture that there's some longer grass. Do you notice how, like, the area where the aircraft is operating, the grass has been kind of trimmed? Well, it turns out that the wind was passing through the tall grass was creating too much, was causing a signal to noise ratio problem. We had too much acoustical interference from just wind brushing through grass. So we had to trim the grass. That way we could get a good quality measurement of a very, very quiet aircraft. Really exciting. A lot of folks talk today about vertiports as a concept, and there's definitely a lot of work going on within the FAA to understand how these aircraft might differ from helicopters, which are the basis aircraft, the design aircraft around which our heliport design standards have been developed over the decades. The Joby aircraft has been developed to operate with the same characteristics as a helicopter, the same takeoff and landing capabilities, precise maneuvering and hover, etc. So when we look at vertiports, what we're really thinking about is how do we get to a scalable future? How do we find new opportunities to connect our regions and communities? In particular, we think that, vertiports as a concept, the pavement and the design is probably just like a heliport, but we believe that a vertiport probably has a meaningful acoustic criteria attached to it. That's that, essentially that agreement with your community, right, in terms of not disrupting them. That compromise that if you come here, right, and you connect us, we really don't want to be waking up in the middle of the night. And I think that, we look forward to the close of the FAA's noise policy review docket this Friday. We'll be talking about single event noise metrics, which, right now are kind of underrepresented, we think, in sort of the FAA's evaluation criteria right now for airports in the NIPIAS. You may have also heard about the SFAR, the Special Federal Aviation Regulation. This is essentially the establishment of the operating rules and rules of the air, qualification pathways for pilots to operate our aircraft and aircraft like it. The short version is that originally this aircraft was going to be type certified as an airplane. The FAA made a decision that actually they preferred to regulate the aircraft as a powered lift. I know that's a trivia term there for you, but essentially that's similar to an Osprey, an AW609. Technically also includes the Harrier and F-35B. So check out that regulatory definition in 14 CFR 1.1 for powered lift. But so the FAA has been developing new rules of the air for powered lift aircraft and pathways for pilots. Joby really sees, the pathway to operate our aircraft as taking an existing commercial pilot at the airplane, helicopter, or powered lift category and giving them a type rating. Model specific training that is suitable for the aircraft to understand the differences in terms of special training areas, special checking areas, in order to operate the aircraft safely. There's definitely flight experience requirements that would be associated with that as well. But in the end, you'd be qualified to fly our powered lift. And so happy to address questions on this if anyone wants to dig in a little bit further. But great progress from the FAA on rulemaking there, and that should be done by December 2024. What does it look like in the cockpit? This is definitely something that's really interesting to many folks. I can tell you, I love flying the simulator in our DC office. It's really a great joy because these controls are actually the same flight controls as the F-35B, the Joint Strike Fighter. It's called Unified Flight Controls. They have a very simplified input, lots of envelope protections to minimize pilot error and make it very easy to operate safely. This lets the pilot really focus on, the other aspects of the flying task, which means, keeping your eyes outside, looking for traffic, being on your radios, thinking about accomplishing that mission, right? And so just to kind of walk you through what it looks like on the flight deck, we have a G3000 avionics suite, very traditional glass cockpit. That'll set us up for IFR operations in the near future, right after our initial certification. But on the left-hand side, we have, instead of a throttle, it's more of a acceleration command. So what we can do is that is a stick that is sprung to center. If you push forward on that left stick, you'll begin accelerating. The further forward that you push it, the faster you'll accelerate. And so if I'm at, let's say, 0 knots and I push forward on that left stick, I'll begin accelerating, let's say at 0.1 or 0.2 G, depending on how far forward I push it. And let's say I get up to 50 knots and I'm happy with that speed. I let go, it springs to center and it holds 50 knots. Nothing about that changes no matter what else I do. I could start climbing, I could start descending, I could turn, the aircraft will hold that 50 knots. So that is another kind of aspect of unified flight controls, is this theory of decoupled axes. On the right stick, it's very much like an airplane. So if I pull back, houses get smaller. If I push forward, the houses get bigger. Also turning or translating if we were in the hover. So left is left, right is right. If I'm flying sort of at cruise speeds, this turn will be a coordinated turn. So there's no real need for yaw input. But let's say that I'm flying on a crosswind day and I want to input a crab. I can use the yaw input by twisting the stick to create that crab. This is also how, when we're hovering, you would essentially point the nose. So that's it. We're coming to the end of the presentation. Happy to do some Q&A. What you're looking at here is the aircraft in front of some model infrastructure. It's really a beautiful sight to see this aircraft in person. I really am looking forward to the days when more folks in New York can see it, feel it, ride it. So thank you so much. Appreciate it.